Our next speaker is Sarah Bird. Sarah has a PhD from Berkeley here under Patterson and Asanovic and Burton Smith. And she's a postdoc researcher at Microsoft Research in New York City, the bachelor from the UT Austin. Come on up. She works on problems at the intersection of systems and machine learning, in particular online machine learning and systems controlled by online machine learning.
Hi, everyone. As Garth said, my name is Sarah Bird, and I am a researcher at Microsoft Research in New York City. And I'm going to talk a bit about the future of intelligent systems. So this sort of taxonomy comes from working with Butler Lamson, and according to Butler, we're in the third wave of applications. And all of these waves sort of start and they never end. And so the first one, which really started in 1950, was using computers for simulation. And so we've got the killer application being the spreadsheet. We're using computers heavily for computation to do things that were happening in the real world. And then in the 80s, we really started seeing the start of the second wave, which is much more about data and information and the movement of it. And so we're calling this one communication. This also includes kind of storing that. And you really started seeing a lot of the applications that we can't live without today. Email and the internet and communicating over that. And I'm claiming that the third wave is engagement applications, and we really started seeing the early part of this about 5 years ago. And so what are engagement applications? And put very simply, they're applications that we're using to help better engage with the world around us, whether that's a digital or a physical world. And so kind of some of the ones that we are hearing about a lot and have appeared in talks today are things like digital assistants that understand our time and our networks and help us connect with manage our daily lives. We've got things like augmented reality that help us interact with the digital and physical world at the same time. The whole smart things movement, right? Having smart infrastructure, having smart homes, everything like that, all the way over to personalized medicine, where we're going to use applications to help us keep our bodies healthier and live longer and everything. And so what I'm going to claim is that the core of these applications are really adaptive learning systems, and that those, in this talk I'm calling intelligent systems, will really demand significant innovation from the systems community, and that these solutions really must be developed together with the learning algorithms. And I think this is a little different than how we've been doing things in the past, where we sort of had applications that we used to inspire our systems work. I think this time around it's really going to be more of a co-evolution. And so to make this point, let's look a little bit more about what I think engagement applications are made of. And so I think there's really two main things that you want to do with an engagement application. The first step is we need to understand the state of the world. And so this is everything from a lot of the big data stuff we've seen where we're aggregating information, we're filtering it, maybe we're abstracting higher order meaning, we're trying to see patterns, maybe see patterns in the states and how we change states, and really do prediction on kind of the state of the world and the patterns around it. And the second step really is we need to make intelligent decisions and take action in the world and understand how and so to do this we need to understand how actions affect the state, we need to optimize for some sort of outcome. And so a lot of the work we've been seeing around, I think, machine learning and big data and intelligence so far is really in this first category. We're just observing patterns and we're making decisions based on the patterns we've observed. And the second category here is where we're starting to use the word AI, whether correctly or incorrectly, a lot more. And I'm going to claim that there's something really different about this second category in terms of how we need to think about our computing systems. So if we look at making decisions in the world, and we want to make intelligent decisions, the first step is that we need to sense, right? And we need to understand what's the contextual information around us, and then we want to take some sort of action and observe what happens. And if we're trying to do this intelligently, we're going to pick an action that hopefully gets outcomes that we like. And what's really different about this than what we've been doing before is this act step. And the point is that this is really, in the most challenging cases, changing the state of the world. And so now the action we take is going to affect, the real state of the world and what data we collect in the future, and a lot of other both challenging learning problems and challenging systems problems. And so it's really this that I think is different and is going to change the way we need to think about systems. And so this is a very far off goal to have a general purpose kind of system like this. This is more when we say AI. But there are technologies today that we're working on in New York, for example, that have a lot of this flavor in a much more simplified form. And so I'm going to talk a little bit about one of those to kind of make this concrete. So one of these technologies is called Contextual bandits. And as you can see, we have sort of the same construction here. We're going to observe the state of the world, we're going to pick some action, and we're going to observe an outcome, and we're going to try to optimize. And the difference is this setting is a lot more limited. We can only handle a small number of actions, and we're assuming that every action is independent. So an action does not change the state of the world. So I don't need to think about sequences of actions. I don't need to think about any of that. I just make a bunch of actions. And so even though this is significantly more limited, there's actually a ton of useful applications for this today. So one that is really easy to show is if I have some sort of online web service and I'm trying to serve content to my user. Maybe I have a user arrive and I have a whole bunch of information about that user. I maybe know what they've read in the past, I know their demographic, maybe I know where they're logging in from. And I'm trying to make the decision of what do I show them? Do I show them, these are news article pictures, a story about food or a story about space? And I'm hoping that I'm going to observe some sort of outcome. They're going to click the story, they're going to read the story. And in this case, I'm doing this over and over again each time a user arrives, and I don't pay attention to the fact that they've arrived before or anything like that. So all of the actions are independent. But this is still incredibly useful. And in New York, we have actually turned this into a service we call the Decision Service. It's a cloud service that allows any application to use this contextual bandit technology to get optimization built into their application. So if I have an application down here, I have my regular application, I still have my user engaging, I have all the information coming, but you can plug our decision engine in, and it will automatically be making that decision for you and sending the information to the cloud, and we will be optimizing as we go. So our system is actually learning. And the great thing about this is now it's really easy for many applications to use this technology. And there's reasons that you would want to use this technology. So we have this in production with MSN now, and here's a slice of one day we were looking at, and compared to editorial results, we're seeing lifts anywhere from 20 to above 50% improvement in clicks, and all of the engagement numbers are going up. And the reason I'm telling you this is to show this kind of online learning technology can be incredibly powerful, and so there's becoming a large demand to put this in many different types of applications, not just news. And so it's easy to kind of imagine that we're going to see this a lot more in our computing systems. And so my claim is that this is game-changing, not just from the machine learning standpoint, but from what it's going to demand of our systems. And for that, I need to tell you a little bit more about how the technology works to understand why this is different. And so one of the important things here is, as I was talking about taking actions, we really, we can't observe an outcome for an action that we don't take. And so if we're trying to learn the value of actions, we actually need to explore over actions. For example, it's very difficult to learn that a user might like a political story if I never show them a political story and give them a chance to click on it. And so as a result, the right thing to do here is to actually randomize over the actions that we select occasionally. And so we call this exploration. And so the real machine learning loop looks something, in practice actually looks something more over here. And most companies and projects are doing these as separate pieces run by people, but we're getting to the point where now you can automate it. And so our service automates all of this. And so you're exploring, collecting the data, optimizing, learning, and redeploying. And so that comes to the second thing. We're using online learning or some sort of form of it, where our model is actually updated every 5 minutes. We can do it even faster. So every 5 minutes, we've got a new model that's responding to clicks from previous users. And this is cool. We're really responsive to changing interest. Suddenly, everyone's interested in something that they'd never been interested in before because of a trending story. And so, we're really responsive. And that's part of the lift. And the third piece I think that's really different here, right, is we are having contextual decisions, right? And the problem here is this is great, right? We're doing personalized news. Different users are seeing different results. But the result is this is a really large action space when it comes to verifying the behavior of the system. We don't know what it's going to do in all of these cases exactly because it's different, and the behavior is changing every 5 minutes, and we're randomizing to run experiments on our users. Okay, so, and while I would say maybe you're not too worried about this in the news setting, it actually is going to matter in a lot of settings, right? And even today, we're already seeing sort of high-profile learning mistakes where this has real-world consequences, the fact that we have, the model constantly changing and all of that. So there was a CMU study last year where they actually showed that Google Ads was discriminating against women, or seems to be. It was showing lower-paying job ads to women than to men. And you can imagine easily that the algorithm was just learning based on what people clicked on. This is not something that anyone programmed into the system, but it's still undesirable behavior, and it has real effects on people's lives and what jobs they might see. And so, this is a real thing that's happening in just an ads application. Microsoft also had a high profile of one of these in the last couple of months, where we have the Tay chatbot, and this was designed to be interacting with people on Twitter, and had the same sort of problem where very quickly, learning through interacting with users, it was saying things that were, implying, offensive language and concepts. And, I'm going to argue, in both of these cases, there are really smart teams working on this, thinking very deeply about these things, and it was still really easy for it suddenly to be, having behavior we weren't expecting. And so this is not, for like a lack of trying. And so I think, we really need systems to help with this. So if we look at kind of the broader challenge that I think we have going forward, and we, like what we were seeing in Randy's talk, for example, these algorithms are becoming infrastructural in our lives. It's not an option to not use them, whether it's in like our real infrastructure or our smartphone. All of that are things that we can't live without and we can't avoid. And so we need to be able to guarantee important properties that we care about, like safety, perhaps privacy, fairness, all sorts of other things in our algorithms as they adapt, as they experiment. And there's a bunch of challenges, as I've sort of talked about, where they have, hard to explain behavior because it's contextual. It changes as a product of the situation it's in. It's also evolving over time. We have to do experimentation to learn. So sometimes we have to be giving maybe a less ideal conditions to someone in order to make our system actually intelligent and adapt. And then there's another problem that most of us aren't interacting with just one of these algorithms. In our real life, we have many of them that we're interacting with, and real learning systems are also often composed of many different algorithms interacting. And so we really have to think about the interaction between these. And so, my feeling is that we can't do this without the system, because systems, runtime, all of that are the thing that is there consistently. We can't have humans in the loop verifying at these time scales or just the general scale. And so we have to build things, we need to use our system toolkit to solve a lot of these problems. So I have sort of two examples of how I think the kinds of things we should think about, but there are many more. So one of these is in New York what we've largely been calling safeguards, but I think it's sort of a limiting term. But the idea is, we really need to think about how to architect the system and abstractions and have mechanisms to control and guide the learning, right? I want to make sure that I don't have the Tay kind of scenario. But the point is, I think this is a lot more complex than simply filtering out. For example, you could easily have our chatbot respond inappropriately to something because it doesn't understand that the content that came in was inappropriate, right? So it doesn't say anything offensive, but it's offensive that it did not react in a certain way to content. And so it's important in some cases that the system actually understands these things, but we still want to guarantee that it's not going to have inappropriate behavior. And so I think there's some things we need to think about here. Can we take the fact that we're getting much better at formal verification and think about, can we actually have specifications about system behavior and really have verifiable behavior in the system while still getting the advantage of our adaptive online learning algorithms? And maybe this looks more like an emergency override at first, and it's really heavy-handed. But in the long term, it would be better if we could coordinate between learning algorithms or understand that cases where a learning algorithm isn't a good choice and roll back to human, right? Mix crowdsourcing in there. So I think there's a lot of opportunities here to really think about what are the new abstractions and specifications and everything to get the power of these learning systems. The second thing is, right in system wheelhouse, and this is efficiency. And I do mean, the traditional kind of, we need to manage the explosion of computation and data movement, right? We cannot spend this much energy per person for every single task, right? And so, in addition to all the work we've already done on big data to make things faster and more efficient, I think we need to go one step further when we're talking about this being in all of our infrastructure. So I think there's many additional problems. And so this is stuff like, instead of collecting all of the data, can we use learning algorithms to decide when to send data and what data we need to collect? There's an area of active learning that looks like this. Can we migrate computation? Can we use contextual algorithms to actually control our systems and make our systems more efficient as they're running? And another one is, can we coordinate with the learning algorithms? And so I'm going to give a more concrete example based on a little research project I have with people in MSR Redmond. And this is called Opal. Opal is the optimization productivity assistant language. It's 4 letters like Dave likes. It's a little bit of a backronym. And what Opal is a language in runtime specifically designed for sort of learning optimization programs. So it's got a lot of stuff built into it. It understands distributions, uncertainty, taking a lot from probabilistic programming. And Opal is now connected up, thanks to Microsoft's chatbot framework, to a nice chatbot and to our Lewis dialogue engine. And Opal now schedules meetings. And it's not great at it yet, but the point is, if I had a conversation like this over here, where I asked Opal to schedule a meeting with Dave, and it came back with times, I might come back and say something like, actually, do you have an earlier time? I don't like meeting in the afternoon, I work in the afternoon, right? And the goal of this system is to actually be able to change my objective function, learn new weights, and adapt, and change my behavior incrementally without losing all of the computation I've already done. So I've explored a bunch of hypothetical options of different scenarios. I've weighed them. I've decided I think this is what you will like best. And now I've said, no, actually, I have a different sort of preference. Can you reuse all of that? And maybe I need to search and look for more. But the idea is, let's actually have the language and the algorithms closely tied so that the language gets smarter and also guides the algorithms. So that's kind of the idea. This is a really simple example. There's a lot more you can do in this space. But at first it comes with understanding both the algorithms very deeply and a lot of our traditional systems toolkit. And so I think there's a lot more we could do. And I think a lot of the problems that need working on, they look like traditional systems problems. We have a lot of experience in this area, and they're just harder now that they're adapted to new things. And I think this is a great opportunity, right? Really need to rethink some of our communication protocols when it's AI agents talking to each other. Are there different computational patterns? Do we need different sort of data abstractions, right? Maybe we need to be constantly logging everything as our features evolve and our models evolve. And so there's a lot of opportunity here. And And so I'm going to claim, there's a great opportunity for systems research to really make intelligent systems a practical reality, right? And have them be integrated in our everyday lives. And I think without significant contributions from the systems community, it's going to be difficult to truly rely on these algorithms for, mission critical tasks. And, with the caveat that we have to do this with the machine learning community as well. This is not something where we can go over and invent this on the side. This is very challenging coordination that's required. And so I'm going to talk a little bit about sort of Dave's legacy in this area. I think we don't always think of Dave as a machine learning person, but obviously Dave has done pretty great sort of systems work that is the foundation for how we've gotten to how far we are. The RAD lab was one of the first, I think, real environments where you were getting systems and machine learning intermixed and thinking about how you change things when they're together. And he has many students working in this area. But I think the biggest thing that I really see is his culture of innovation, right? The Dave Lab projects have always been about people from different areas moving in together for 5 years, right? And so you can only get this tightly coordinated level of innovation that I'm talking about that I think we need when people are willing to invest spending 5 years together learning each other's languages and innovating together, right? And not just having a meeting and going their separate ways. And so I think we are seeing a lot of innovation coming from Berkeley in this area because the students have a culture of this, of really getting to know other areas and cross-pollinate across them. And so I think that's going to be one of Dave's biggest legacies in this area going forward. And I think that's all I have. So I've got a bunch of references for things I casually mentioned, and I will take questions.
Hi, John Osterhout. I have more of a comment than a question. Mm-hmm. So my comment is related to the learning errors you talked about. Mm-hmm. So I hypothesize that it is a fundamental property of any system that learns that it will develop bad habits. And I've been experiencing this myself for 20 years. I've been using speech dictation systems which attempt to learn from your input, and my experience is that over time they actually get worse and worse and worse with more and more bad habits, and I eventually realized the best way to use the system was to do the initial training and then turn off learning and don't let it learn anymore after that. I've tried this idea on my AI faculty colleagues at Stanford. They think this is bunk. But I actually think that'd be an interesting area of research to try and understand what is the process by which bad habits form and see if we can, in fact, make computers that don't develop bad habits. And then if we can do that, maybe we could actually apply that to humans as well.
Yeah, so I think I think we're observing that in practice a lot too, and like short term, this actually again starts sounding like systems problems about checkpointing, rolling back, right, unlearning things. But it's true that we another thing to do in this area is study human behavior, and so in New York we actually work with a lot of social scientists and study this coming much more from the human angle as well as coming, from the deep technology angle. And I actually think that's a, important thing to do in this space because we now are talking about things that are changing how our society works, right? And it's crazy that we're just coming in only as computer scientists in this. And so I think it is important to kind of look at how human learning goes as well and how humans interact when we start talking about interacting with algorithms.
Hi, Sarah.
Hi.
Dave Edstrom. Great talk. And the question I have is when Elon Musk, who is investing in AI, came out at MIT and said that he believes that AI is the greatest existential threat to humanity and that it may need to be regulated. What were your thoughts when you first heard that?
So,
Thanks.
Yeah, so my personal feeling is what Elon Musk is talking about and Nick Bostrom and others is this longer-term AI future that, may not happen in our lifetimes. It may. And I think it's important to think about those things, but I think it's unfortunate that we're getting a lot more attention way out there when we have problems right now. We have our learning systems discriminating and many other sorts of problems. And so my feeling is I don't have a problem with what they're saying, but I wish we got sort of equal amount of attention around the issues we have about regulating these kind of things today and how we're actually going to make them work in our legal framework today. So, yeah.
I have a question. You and I were talking last night about the forum for machine learning systems. It seems like the NIPS community and the ASPLOS community are pretty far apart. Are we making progress in finding a community for machine learning systems?
So the discussion we had last night is we are seeing it appear everywhere and in every conference, which is really exciting to see so much interest in it. But I think it would be great if we formed a stronger community. And there's so many different types of machine learning systems, and it would be great if we were talking and learning. And so I think we're hoping maybe there will be some sort of workshop starting and see if we can form a bit more of a community. So if you're interested, let me know.
So quick question, you had said something about turning sci-fi fantasy into more real stuff. So do you have some either favorite or unfavorite stories, okay, or books of futures that might be good or that might be bad involved with this?
Yeah, absolutely. I feel like even when we were talking about Singapore a little while ago, I was feeling that very much triggers a 1984 situation for me, and I don't want these sort of technologies to lead to surveillance state or any sort of problems like that, or more enforcement. My excitement personally, for those that know me, I love efficiency. I would like this technology to just work and be personalized and do the things how I would like them to be done. And so most of my excitement comes around applications that are going to save people time so that they can work on the things that they're really passionate about. And so yeah, I'm much more excited about the personal assistant or personalized medicine directions.
Catherine McKinley, Microsoft Research. So I'm in programming languages. We've spent a lot of time and 50 years in programming languages trying to design languages and verify that the systems and applications that people build are correct. So what I see as a common theme in the talk from the man from Holy Cross and also in the examples you use from Google and Microsoft about things going bad is data is bad. And we haven't felt, how do we identify bad data? How do we generalize what we've been able to do for programs to understanding data? And so, yes, we're going to form bad habits because we have bad data coming in. And how do we recognize that to keep that from happening? And that level of semantic understanding of the data is, I think, something we haven't talked about yet today, yet seems fundamental to all these problems. Do you have any thoughts in this system architecture for how to deal with that?
Yeah, I completely agree that that's one of the biggest challenges going forward. And this is sort of one of the ways that I think we're going to need to guide the learning algorithms, because they need to understand the difference between good and bad data. We can't just filter bad data, and we're not even at the point where we really can intelligently filter bad data if we wanted to. And so I think there's a huge language component in this story, and I don't know if we're even close yet, but I think it's really important that we work on it.
Hi, Jeff from Google. So part of the challenge of doing real life things for people that are really useful is that it's super long tail. So it's really hard to generalize and come up with a good solution. Curious if you had any insights on that.
Yeah, I think that's one of the reasons I'm excited about these contextual learning algorithms, is because they are designed to be personalizing, and I think we are seeing a lot of lift in even the simple scenarios we have around the fact that we are now hitting those different categories of users, and when we were only having a metric that looked at one, there's a lot that are really underserved, right? And so I do think that this adaptive learning is part of that solution. There are huge challenges around how do we understand when we are doing better, especially when you're over a mixed population. When we talk about experimentation, there's concerns about experimenting unevenly on different populations, or one is getting kind of all the cost while the others are getting all the benefit. And so we're still going to have all of these long tail problems, but as far as user experience goes, to me, these contextual learning algorithms are really the first step into making something that's practically useful. Because, yeah, as we're saying, our lives are also very situation dependent, right? We change personas. I want different things happening when I'm my regular day and when I travel and so I don't think any of the technologies I mentioned are going to be very useful until they're contextual. And so that's why I believe very much in this technology. But as I said, there's tons of really hard problems. So that's why I think it's important we start working in now and figure out how are we going to make them fit with real life now.
Mr. Nikravesh is Scry. So I think I counter some of the comments about the mistake or bad behavior of the AI, because what is the bad behavior? If your model is a human and you want to be the system be as human as possible, so that's part of the system. So bad behavior, it is part of being a human. So it depends on which model really is trying to model. If it's a human, then the bad behavior is always going to be part of it. And he's taking that one is not about the bad data.
Yeah.
Data is the data. Is what the decision and what the model you're building is the one that the relevance to all these behavior and decision you're making. That's just a comment.
Yeah, so I think even with humans, right, we try to train them to be representative of our organization or of our family, or right. There's different ways we try to guide human behavior, and so part of the story is also figuring out how do we make sure that we train and guide these things to behave as a representative of whatever we want them to be, even if they are sort of still human. So right now it doesn't feel like we have a lot of control over that.
Let's thank our speaker.